morning everyone, we are back with another leetcode question. The question name is Maximal Range, question number 85. Given rows cross columns, binary matrix filled with both zeros and 1, find the largest rectangle contain only 1 and return its area. Okay, so we have to return the maximum area of a rectangle in this matrix. Okay, so yeah, I'll just go through the steps which we are going to go through to solve this question. So first off, we are going to make another matrix that is going to be storing the sum of the current consecutive ones, or it's gonna be storing the count of the current consecutive ones. And it's gonna be storing 3 here, 2 here, 1 here, because here the number here will tell us that how many ones are sticked to this one before this one. So here the only one number is, that is this number itself, but here it will show 2 because there are one more number or one more one attached to this, and here it will show 3. Similarly 3, 2, 1, 1, 1, 2, 1, 1, 1, 0, 0, 1, 0, 0. It will show something like this. Okay, so I'll just redraw it here. One more. So 1, 0, 1, 0, 0. Right again. 1, 0, 1, 1. Sorry, 1, 2, 3 here. Again 1, 2. Sorry, it will show 1, 2, 3, 4 and 5 here, right? Because there are consecutive 5s ones here. 2, 3, 4, 5. Okay, 1, 0, 0, 1, 0, something like this. It will be something like this. Now after we have constructed this, then we are gonna go through all the rows. Okay, so we are gonna go through all the rows. Okay, so let's suppose we are at this row, and then we'll take this rows data. Here I'll write it like this. Sorry, this columns data, I'll write it like this. Okay, so yeah, so what does this column say? 3, 0, 3, 5, 0. Okay, what does this column say? This column says that here at this position there is no tower, I mean no one here, no number of ones, 0 number of ones. And at this position it says that here is a tower of length 3. As you can see, the tower is of length 3. And here this says that here is a tower of length 5. Right? There you can see tower is of length 5, right? So this is what this data says, right? So now what do we need to find? We need to find the maximum rectangle. So it can be either this rectangle or it can be either this rectangle. Either this rectangle, right? So which one is maximum? We just have to find it using this method. So let's suppose we have a column data which is a little different from this. We just write random numbers. Let's write 2, 3, 4, 5, 3. Okay, so what does this say? This is a tower of length 2. Here is a tower of length 3, and again length 4, and again length 5, right? And again length of 3 here. So here we can determine the largest rectangle using a stack, right? So here we have to just check for this position. We have to check that how long can this position go on to make a rectangle. So here there is a, it can make only this, but this position can make a rectangle till this position. Okay, so this 3 can join with this 3 to make a bigger rectangle, which will be of dimensions 3 cross 4, right? So 3 cross 4, that will be 12, and here 4 cross 2, that is going to be 8, and here 5 cross 1, that is going to be 5. So this here are going to be these number of rectangles here. This rectangle will be of 8, this rectangle will be of area 5, and another rectangle 2 cross 6, right? The 2 cross 5, 2 3 4 5, right? The 2 cross 5 will also be of, so this rectangle will be of area 10. So we can see that our 3 cross 4 is biggest, right? So we have to find a way to calculate the maximum size rectangle after making this column data, using this column data, right? So we have now make the problem even simpler, right? So how can we do that? We can do that using stack here. I'll just show you how can we do it. So I'll just get rid of this, or I'll just make a screen. Yeah, I should get rid of this. Okay, so I get rid of this, get rid of everything. Okay. So let's now suppose that we have our column here. This is our column data. What is this? This is our column data. Okay, so let's write any random numbers here. I'll write 2, then I'll write 3, then I'll write a number which is even bigger than 3, that is going to be 4, then I'll write a number which is smaller, which is going to be 2, then I'll write again a number which is bigger, 6, anything random, 7. Okay, so now what does this say? We have a tower here, 2 of length 2, 3, 4, again 2, then 6, that is very big, 4, 5, 6, like this, something like this, then 7, that is gonna be 1 minute bigger than 6. Yeah, so now let's suppose we have a column data like this. So how we can calculate? So we will be using stack here. Let's say we're gonna be storing the value and the index both in stacks like this, in pairs, like the value and index for for this position is going to be 0, the index, and 2. Okay, so sorry, index and value, so I comma v, index and value. Okay, and for this the index value pair is going to be 1 comma 3. Similarly for this 2 comma 4, and for this 3 comma 2, for this 4 comma 6, for this 5 comma 7, right? Something like this. So these are the values we are going to be storing in our stacks. So let's say we have a stack, right? For at initially the stack is going to be empty, right? So now we then after declaring the stack, we're going to be traversing in our this row data. Okay, so let's suppose we are at this position, and now we see that our stack is empty. So what we'll do, if our stack is empty, we'll simply push the current data in it. So we'll just simply push the current data. Thus our stack will become 0 comma 2. Now again we jump to this position. Now what we see, that now we have to check that if is the stacks, I mean the last value in our stack, is the value of the last value greater than sorry, is the value of the stack which is prior in the stack is smaller. If it is smaller, we simply push it again. So now if it's smaller, I mean the previous value is smaller than the current value, then we will be pushing it. Okay, so we will be pushing it 0 sorry, what is it, 1 comma 3, 1 comma 3. Okay, now again we will be jumping to 4. Again we will be checking if the current value is greater than the last value. We will be again pushing it. So again it's going to be 2 comma 4. Now again we'll be checking if the current value is less than the last stack value, then what we will do, we'll check that how long does the this we will just first off we'll just pop this value until we'll be pop this while. How long are we gonna pop? While the current value is smaller than previous stack. So while this condition satisfy, we are gonna be popping, and after popping we're gonna be checking the duration, this number which we just popped, or this element, like this element, how long does this served us. We're gonna be checking that. So for 4, how we're going to be checking, we are going to be our current index. What is our current index? Our current index is 3, so right, and then we are going to be checking that how long does this current row served us. So by served us I mean how long was it with us, or in other words we can say that what duration, what distance was it in the stack. How long distance was it in the stack. So it will be I minus the index of the popped element, which is going to be 2. Okay, so I minus 2. So our current I is equals to 3, and it's 3 minus 2 is going to be 1. That means our 4 was only for duration 1, that is 1. I mean the so this will help us create the maximum rectangle which this 4 could have formed. Okay, so that is going to be the duration it stayed into the height, that is going to be 4. So we're going to be storing that v1 equals to 4. Okay, p1. Okay, popped 1. Okay, now again we have popped this element, right? So we'll get rid of this. So we have popped this element. Now what do we have? We have 1 comma 3. So the next previous value is 3. So we will again be checking, is the next value again smaller than this, while as you can see here we are using while loop. So again it will be checking that. So yeah, it will show yes, it is smaller, it is bigger. Our current is smaller and our previous is bigger, right? So again we are gonna do the pop operation. So again we will pop this, and what is the duration this served us. I mean what is the index of this popped value, that is 1, right? What is our current index, that is 3. So again 3 minus 1 into the height of this, that is 3, right? So 3 minus 1, that is going to be 6. So our P2 is going to be 6. You can see here this 2, I mean this 3 was for us for duration of 2, right? As you can see, for duration of 2. So this is making this rectangle which is of dimension 3 cross 2, right? So this is giving us the area of 6. We are just going to be storing all these pop values, and at the end we are going to be returning the maximum out of it. Now again, that we have deleted this, right? We have popped this. So again our stacks look something like this, right? Now again what we will check, is the current smaller than the previous, and we see that no, the current is not smaller. In fact it is equals to our previous. So we'll do nothing. Again we will push it like we did here. So if it's greater than the previous or equals to the previous, we will simply push it. No, we will not push it, we do not do anything, and we will move on to the next element, right? So we move on to 6. Now we check, is the 6 is the current, and is the current value which is 6 smaller than the previous value? No, it's not smaller, so it's greater, right? So we are simply gonna be pushing it into our stack. So our stack will be something like 4 comma 6. We push it again. Now again we reach this last element. Again we check it, is the last element, or is the current element greater than, is the current element smaller than the previous element? No, it's not smaller. So we'll simply push it, which is we'll be pushing 5 comma 7. Now again we will now pop all the elements, and we will perform this operation using our current index, and we'll be changing our current index to one more. Like if the previous index was 5, then we will be doing I plus 5, and our current index will be equals to 6, right? Now using this current index, we will be popping all the elements and performing the calculation. So when we pop this, what do we see? We see that 5 comma 7, right? And how long did this element served us, or how long was this element in the stack? This was for 6 minus 5 duration. So what is the area this element could have provided us? The maximum area, that is going to be into the height of this, so which is will be 7, because 6 minus 1 equals to 1, and that multiplied by 7 is going to be 7. So P3 is going to be 7, right? Now again, after doing this operation, we have popped this, right? So let's forget about this. Now we have to pop this again. We see that our current index is 6. So how long does this popped element served us? This was for 6 minus 4, and what is the maximum area it could have given us? That is going to be 6, right? Because the height is 6. So what will it be? 6 minus 4, 2 into 6, that will be P4 equals to 12. 6 into 2, 12. Okay. Now again, forget about this. After popping, we forget about this. Now again, we come to the last element, that is 0 comma 2. So how does this element served us? So this served us the longest, which is going to be 6 minus 0, right? 2 3 4 5 6, yeah, 6 minus 0. And now what is the area it will give us? It will give us into 2, which is going to be 12, right? So as you can see here, this element is giving us the area of something looking like this rectangle, which will be of dimension 6 cross 2, and this element is giving us a rectangle of this, which is 6 cross 2 as well, and this is giving us a rectangle of 7 cross 1. So as you can see here, using stack, we are able to calculate the maximum maximum rectangles, which all the rectangles which can be formed, and then we can pick the one which is maximum. Like here, in this case it is 2. So let's jump to the code. I'll just get rid of these things so that it's clear. Okay, or should it have, yeah. So I'll just erase this part only, just to make some space so that you can view the code. And so first step, what is the first step? First step, we need to create our sum matrix. Okay, so first step is going to be, let's declare a smat, which is going to be storing the sum matrix. Let's just rename it to mat, just for convenience, and is going to be, let's forget about that, for I in range of length of mat, for j in range of length of mat 0. So right now we are just creating, I'll just write creating the sum row mat, okay, sum of rows, or I should write consecutive one. Okay, so we are writing sum of consecutive one. Okay, so we are creating the sum consecutive one row matrix X. Yeah, whatever. So yeah, creating this matrix here, right? So I test this for loop. Right. So yeah, we are just creating the sum matrix. So we need another for loop for this, right? And also we need an empty variable, a temporary row, t row, which will be an empty row. Okay, temporary row also, and for j in range of. Okay, so something happened here. Okay, I didn't, you know. So it should be like this for I in range, or we should just directly, I was thinking, nah, anyways, we have to do it. So for j in row of mat, range length of mat 0. So yeah, then t row dot append. We also need s here, which will be 0. Yeah, so first of s plus equals to one thing here. If our mat I j is equals to 1, then we will add and else equals to 0. Okay, and then we will be appending as in our temporary row. Okay, yeah, something like this. Yeah, so I'll just print this temporary s mat to you, just to so that you can see what we have done here. Just get rid of these. Okay, so I'll be printing our s mat here. So this is our s mat. Let's see. Invalid syntax. Okay, no problem. smat is not defined. How can you say that, man? Smat is defined. Okay, so zero dot append. And here smat dot append t. Okay, we forgot to do this. Now let's try to run it. Oh, sorry, smat. It should be smat, right? I wrote the spelling wrong. That's why it was showing the error. So now here you can see that we have created our sum matrix here, which will contain the, earlier I explained you that this will contain 1 2 3 4 5 1 2 3 1 1 1 1 1. So we have created this matrix here, 1 0 1 2 3 1 2 3 4 5. Yeah, right here. Now what do we need? So in Python we cannot send we have to send our columns to make this column, right? We have to calculate our calculate our answer using the columns data, but we have rows here, right? So what we will do here, we will convert the columns into rows so that we can pass those columns which are now rows in form of rows in the function to calculate this data, right? So yes, I'll do that. For that we're gonna be running another for loop, and we're gonna be declaring another column smat, This is the S mat which we have just flipped. We have converted the rows into columns. That's it. That's it. So that is will be empty. So we are just gonna be flipping the matrix here. So for I in range, I'll just copy paste this, or should I just rewrite? Okay, no problem rewriting. For J in range, mat of 0. For I, length of mat, and a temporary column TCOL is going to be equals to empty matrix, and T dot append as T of I J. Okay, and our call as column submatrix, which is called smat dot append T temporary column, and print as column smat here, and return 0. Again, I'll just show you what we have created now, like what we did in this part of the code. Okay, so this will show you that. I'll just run it again. Okay, T call, it should be T call, right? So what we did here, we just changed our rows into columns and columns into rows. So here, this column 1 1 1, which should contain only ones, is here. This column 0 0 2 0 is here, 0 0 2 0. This column 1 1 1, sorry, 1 1 3 0 is here, 1 1 3 0. This column, which should contain 1 2 4 1, this is also here. Sorry, 0 2 4 1, yeah, 0 2 4 1 is here. 0 3 5 0 is also here. Now, yeah, now I'm gonna be making another function, just just to make not make it the code very complex. I'll use I'll write the rest of the part in a function here. So in our function, let's name it max height or max rectangle. Okay, so this will be receiving an array which will be the column. Okay, so or we can call it column, no problem. Yeah, so we'll be receiving a column here, like this column. Okay, and what we are going to be doing, as we have discussed, we're going to be declaring a stack that is going to be empty. Again, what are you going to do here now? So we have declared our stack. Now we'll be traversing in our column for A in, or for I in range length of column. Okay, now what do we need to check? If our stack is our length of stack is 0, means if our stack is empty, or the top element in the stack, that is start minus 1's value, as you can see, we are storing this in a in a list of 2 elements, so the value is going to be at position 1. If the value of the top element in our stack is less than, no, not less than, is greater than our sorry, it's less than, it will be it's less than, yeah. If it is less than our current value, which is our column of I, if these any of these two conditions satisfy, we're gonna be simply pushing it in our stack, pushing the current element. The current element is going to be pushed in a list where the first index will contain the index of that element, which is going to be I. The second is containing the value, which is going to be column of I, right? So after doing this, now we will check if the length of stack is not 0. That means if the length of stack is not 0, or no, sorry, and it should be and, right? So yeah, and if our length of stack is not 0 and the current value, that is column of I, is less, it's not greater, is less than the topmost value in our stack. If this condition satisfies, what should we do? So we will be popping it out. So how long are we going to be popping? So first off, we'll just declare an X here, or yeah, so we'll just declare an X here, or we can declare some value max equals to 0 here. So yeah, so while this condition is present, I mean it is valid, we will be popping out elements, and also we're gonna be checking the values of the rectangles formed by these elements, right? So how we're gonna be checking the rectangles? So let's say A is the topmost element. A is gonna be column stack dot pop. That means the topmost element which we just popped after checking that it was smaller, it was smaller than our current, it was greater than our current element. So now we're going to be checking that how long did this this current popped element, I mean the last stack element, served us. So it served us for, so we'll store the value directly. So x will be equals to I minus a0, right? So this served us for I minus a0 time, and we'll multiply it to the height of that tower, or height of that popped element, which is going to be equals to the first index of the popped element. So yeah, this is our rectangle area which this A, or which the stack's popped element gave us, which could have given us, or this is the maximum area of rectangle which could have been made using this A, okay, height of this A at this current situation. So what we just need to store the max value here, x comma max, right? Just for we just storing this value, this x max, yeah, max should be equals to, I just wrote it the wrong way, max should be equals to max of x comma, so yeah, and this operation will be going on until we reach a point where either the stack got empty, or the element which is at the top of the stack is smaller than the current element, or equals to the current element. So if we reach that position, what do we do? So if if this So yeah, there can be two cases. So here can be two cases in which this while loop will stop. Either the stack got empty or the current element is equals to the value of the last element in the stack. So we have to just keep in mind that we don't have to do anything if the element is equals to the value in stack, like the case of this 2. And when we were here, we didn't do anything. We don't need to push another 2 here. We just need to move on. So yeah, we'll just move on in that case. And else, if this is not the case, I mean if the value current I value is greater than the element in the top of the stack, and this is not the case, I mean the stack is not empty. If the stack is not empty, I mean if our stack is not empty and the current element is equals to 0, I mean equals to the topmost element, then we have to do nothing. That means we have to continue, right? Else, and if it's not the case, we will be appending. So stack, if that's not the case, what we'll do, we'll simply append I comma column of I, right? So here we checked, we popped until we reach a point where it is either equals to or smaller than the current element, and if it's equals to, we did nothing, we just continued, and if it is smaller, then we appended the current indexed data. Okay, so now we have gone through all the trouble, but we are at now this position that we are at a position where we have passed, we have checked all the data in our column, right? So we are at this position now. We have reached the end of our column list. So what do we need to do? We need to now simply pop out all the elements present in the stack, and we need to calculate this value. And our current index, I mean our current I will be, current index will be I1, right? Because this for loop will end, this for loop, okay, sorry. So yeah, I need to write it somewhere out of this for loop, right? So after this for loop has ended, now I will be equals to length of column minus 1, but we need to make the I equals to the length, right? So we'll just do I plus 1, and now what do we need to do? We need to simply pop out all the elements that are now present in the stack after completing this for loop. Okay, and we have to perform this operation. So now simply while stack is not empty, while so we will just pop out element, we will just copy paste, and then our temporary variable is going to be storing I minus a 0 into I, yeah, same thing. Okay, we will be checking our updating our max value, and at the end of the function we will be returning max, because this max is the maximum rectangle which we got after doing all the operations. So what do we need to return here? We need to return here also, we need another max variable, max equals to 0, and for all the columns, column in this our columns matrix, columns matrix, we have to perform this whole operation, right? So, and we will store that into an x. X is going to be storing uh, the value returned by this function, and we have to pass the column inside the function, and we have to check if the max equals to max of x comma x, right? So yeah, and at the end we will be returning the max. Okay. So let's now check if our solution is running. Invalid syntax somewhere in line 12. So yeah, we did something wrong. What did we do wrong here? It should be equals to. Okay. As you can see, we are getting correct answer for at least these 3 test cases. And what are we printing here? So we need to get rid of all the prints here. This one and this one. Okay, now let's run it again, and we will be submitting our code now. Run it this. See what do we. If we get a successful submission and we get a wrong answer, okay, we don't need to panic. Just have to check why did we get this wrong answer. So we'll just copy this test case and we will be pasting it here, and then we'll be reactivating our prints and all those. So we might have missed out on something while writing our code. It happens usually. So after checking it, we will get to know what have we missed out on. So I'll just go through the code once. Why don't we just run this and see what is wrong here. So yeah, this looks like a fair amount of trouble here, and what I'm going to be doing is I'm going to be printing column and the output of the column. Okay, so I'm going to be printing and the output column versus the output of the column, because our main operation lies in this max rectangle function. So that's not working properly. That means there is some issue, right? So here it is working properly, right? Because the maximum what it can give here is 2. But in this case, the maximum can be of 1, 2, 3, 4, 5, or it can be of, yeah, hold on. So here it shows 4. I totally understood. But what about this one? 3, 2, 3, 2, 2, 2. Okay, so here also should have shown 2, 3, 4. Yeah, it should have returned 8 here, but it has returned us only, it's returning less values than it should. Here it should return 2, 4. So it should return 4 here, which it is returning. Okay. Okay, what are we doing wrong here? Yeah, going through the length. Yeah, we are doing it. We are doing like this one here as well. So what is wrong that we are doing here? I think something might be wrong here. After this while loop ends, Yeah, I think I know what's wrong here. Or do I? Okay, I have to, check. So I think here, we're doing something wrong. That is, what we should do here is, yeah, we missed out a case here. Like, just imagine if this 2 was not there, okay? I'll just get rid of this 2. Just get rid of this 2, okay? So just imagine if we had an array like this and we reach this 2, okay? So what we did here, usually what we do here, if we reach this position, we simply pop out all the elements that are prior to these elements which are greater, and if we reach a point where we don't have any element, we simply push this element, right? But in fact, what we should, push the we should simply push the index of this element with the value of this element, right? But we should not push the index of this element, because if you put the current index of this element, then we will be in future we will be calculating only this part of the rectangle. What we need to do is we need to push the index of the last element which got popped, which was greater than this element. So we should be pushing the index of 3 here. So that will give us the right answers. That's what happening wrong here. So we just need to, remember the last element which got popped out because it was greater than the current element, and we need to push that index in our current, when we are appending this. Okay, so we just do the changes. We'll just do those changes here. So yeah, I'll be declaring an index here, ti, that is going to be 0. I do really need to do that. Okay, and here whenever we pop out, I'm just going to save that ti. Temporary index is going to be the index of a. Okay, and when we are appending this here, we are going to be using our temporary index. So for that case where we for like the case of 2 where we have popped out 4 and 3, so we are gonna be pushing the value of 2 with the index of 3, so that will just solve the problem. Let's try and run it again. As you can see, it solved the problem. I detected the problem. Okay, now again we will be submitting it, and let's see if we are a successful submission. I'll just get rid of these 2 lines, or else it will show output limit exceeded. I'll also get rid of this line. Okay, yeah, so now let's try to submit it. We have a successful submission, and the submission beat 73.69% of the users. Yeah, thank you for watching. I hope you understood.